Welcome to tutorial video number 2 for ExpressSCH. I'm actually going to start by looking closely at our pressure sensor, the 47030A, and point out when you look at this, so this is a bottom view because I can see the pins, right, sticking out the bottom, but if you're looking at your sensor, you're going to see that this has been put in an 8-pin dip, or that is to say an 8-pin standard header, so that 1 is the top left connection. It goes 1, 2, 3, 4, 5, 6, 7, 8 coming back around the U. So if you were to rotate this 180 degrees so that you are looking top down at the sensor, I just want to be real clear that that this is the sensor that we wire backwards the most. It's the sensor that students put in SCH, well, not in SCH, but in PCB backwards the most. It's the one we have to resolder most often. So, so be aware, I know they numbered them 4 through 12 for whatever reason. When you're looking at a standard header, so if we flip this 180 degrees so it's top view, you'll have pin 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so just be aware of that. And then the numbers correlate down here. 4 is an output, 5 is 5 volts, 10 is an output, 6 is ground, 7 through 12 are not used. 7, 9, 11, and 12 are not used. Okay, so here are my 4 pins that I need to wire, and 4 of them are not used. Okay, so that was not ExpressSCH at all. That was an explanation of the pressure sensor. So we come over here, wherever I left it, ExpressSCH. And so the first thing I'm going to do is a little bit of an art project. This works kind of like paint. I'm going to put in my box for my pressure sensor. I'm going to place pins. So I've got, I just said 4, 5, 6, 7, 9, 10, 11, 12. Okay. I'm going to put some artwork here to connect my pins. Oops. And I right click at the end of every line. So like I said, this is a little bit of art to represent my sensor. The geometry is far more critical in my PCB software because this is a representative schematic. What I do want to get right is the fact that I have pins. So this is pin 4, and I'm going to name it the same as my spec sheet so that it's easier to correlate my pins. And I'm going backwards now. Oh, no, something went wrong. Hold on. Four, 5, 6, 7. Oh no, it's perfect. 9, 10, 11, 12. I'm just having trouble counting backwards. Okay, so 4, 5, 6, 7, 9, 10, 11, 12. I'm going to make this a little bit smaller so that I can see both at the same time. And recall that 4 is V out. Plus V out. 5 is 5 volts. I'm going to need to move these around a little bit, but I'm just trying to make some notes to make it easier for myself later. 10 is negative V out. And let's see. 6 is ground, which is off the screen. Here it is. 6 is ground. 7, 9, 11, and 12 are unwired. 6 is ground. Okay, so now I'm going to zoom in a little bit and move things around. 4 is V out. But you know what? We'll put 4, maybe we'll put these inside. So I didn't quite make this big enough. When you make yours, feel free to make it a little bit big so that you can really see what everything's doing, okay? I'm going to put, okay. So now the very last step is I'm going to highlight this and I'm going to come up to component and group to make a component. Because right now this is artwork with some numbered pins. So I need to turn this into a component. I'm going to group it and we're going to call this U1 because it's the first sensor I've made. And I'm going to give it a name 47-030A because that's the part name. You can also put like an actual part number at DigiKey or whatnot. And that comes here. Okay, so now I need to wire. You know what? We can make this big again. So I need to wire a ground. So I'm going to bring a ground over. And I need to wire a 5 volts. So I'm going to go ahead and bring a 5 volts over. Just remember, copy, paste. It's a little bit easier. And then I need to wire my output voltage to my connector. Okay, so I'm going to grab my output voltage. Say I put this on pin 2. And, oh, you know what? We'll move that to pin 3. So that this can come neatly to pin 2. And I have to wire my ground. I'm not going to leave that angled. Oops, not the escape key. The right click and then select. And I think I can just shift that up a little. Ground can maybe come in. You know, we could probably move this around to make it a little bit less cluttered. Then again, maybe it's not. Oh, there we go. Okay, so now this component is fully wired up. I have unwired terminals, and that's okay. I've connected pins 2 and 3. So what you need to do is you need to make 4 of these sensors. So here's U1. You need to make a sensor for wind speed, for temperature that uses this resistor, for humidity, and temperature and humidity will be one piece of art, even though it's 2 separate functions. It's a single piece, it's a single component. And then finally, wind direction, the MA3. So you're going to wire all of these up. And your very last step is going to be to save this on your L drive and then check for errors. And what happens with the netlist file is if you have unnamed components, or if you have unnamed pins, So you need to have pin numbers and you need to have component names. Then you're going to find netlist errors. And if you don't have any netlist errors, this is ready to get linked to a PCB file. And so stay tuned for future videos on ExpressPCB, but this is sufficient to get you a full ExpressSCH schematic file that contains one 8-pin connector, 2 resistors, one polarized capacitor, and 4 custom components that you make yourself. I will show you, just remember one last time, component and symbol managers for those custom or standard library symbols and library components. Okay, that concludes this video. Ask with questions.